So when we have a molecule that has no lone pairs on the central atom, it's actually really easy to figure out what the geometry is, because the steric number is equal to the number of atoms that are bound to the central atom. So remember, remember that the steric number is the number of atoms bonded to a central atom plus the number of lone pairs on the central atom. So if there are no lone pairs on the central atom, then the steric number is equal to the number of atoms that are bonded to it. So no lone pairs on the central atom means that if there are 2 atoms bonded to the central atom, we have a steric number of 2. 3 atoms bonded to the central atom, steric number of 3. 4 atoms bonded to the central atom, we have a steric number of 4, 5, and 6. So you must draw your Lewis dot structure first to see if there are any lone pairs on the central atom. If there are no lone pairs, then the steric number is equal to the number of atoms bonded to that central atom. Now, we can use geometry to determine what the shape and the bond angles are based on the fact that electron pairs want to be as far apart from one another as possible. So if there are 2 atoms bonded to a central atom, the way that these 2 atoms can be as far away as possible is in a linear geometry where the bond angle is 180. So if there are no lone pairs in the central atom and there are 2 atoms bonded to that central atom, the shape is linear and the bond angles are 180 degrees. Okay, now let's look if there are 3 electron pairs around a central atom. The way that 3 electron pairs can be as far away from each other as possible is if the bond angles are 120 degrees. Each bond angle is 120 degrees. That will get those electrons as far away from each other as possible. When the steric number is 3 and there are no lone pairs in the central atom, the shape that the molecule forms is known as trigonal planar. Trigonal planar. All 4 atoms are in the same plane. So if we look at boron trifluoride and we drew out the Lewis dot structure for it, we would see that there would be no lone pairs on the central atom. Since there are 3 atoms around that central atom, the steric number is 3, and the geometry is going to be trigonal planar with bond angles of 120. Now let's look at another chemical, carbon tetrachloride. If we draw out the Lewis dot structure for carbon tetrachloride, we find that there are no lone pairs on the central atom. Therefore, since there are 4 atoms bonded to that central atom of carbon, there's a steric number of 4. Well, the way that these 4 electron pairs in the bonds can be as far away from each other as possible is known as a tetrahedral configuration. And this bond angle is going to be 109.5, and this is geometrically determined. And on this PowerPoint there is a graphic that is shown as your textbook where we have these forms made from balloons. If we have a balloon, 2 balloons, how can they be as far apart from one another? 3 or 4. So no matter what we're looking at, whether it's bonds or balloons or even pine cones. One time I found a pine cone that had 4 pine cones, and 5 pine cones came out from a central place, and they had the tetrahedral and then this geometry here. So it's not just electron bonds. Anything that's trying to get as far apart from one another, starting from a central location, is going to assume this geometry. Now we're only going to look at steric number 4. So if we have a steric number 4 and no lone pairs in the central atom, then we know that molecular geometry is tetrahedral. So let's take a look at this Lewis dot structure. Carbon's our central atom. Take a minute to look at it and come up with what you think the geometry is. So we notice there are no lone pairs on the central atom. There are 3 atoms attached to that central atom, and so that means that this molecule is trigonal planar. And it also means that our bond angles are going to be approximately 120 degrees. Okay, let's look at the Lewis dot structure of carbon dioxide. We notice our central atom of carbon has no lone pairs. So it has 2 atoms bonded to it, so it has a steric number of 2, and its geometry is going to be linear. Here's a Lewis dot structure of there should be a -1 up here, of the nitrate polyatomic ion. We notice our central atom, nitrogen, has no lone pairs, and it has 3 atoms around it. Therefore, we know it has to be trigonal planar, and with bond angles of approximately 120. Now notice that the Lewis dot structure does not represent these angles. When we draw a Lewis dot structure, we tend to draw our bonds at 90-degree angles. So the Lewis dot structure just tells us how many lone pairs are in the central atom and how many bonding atoms there are around it. That's what we care about to figure out what the molecular geometry is going to be.